Welcome to the Mathnasium University Write Materials Numerical Fluency Assessment course. In this course, you will learn the importance of number facts and numerical fluency, the methodology behind the numerical fluency program, the structure of numerical fluency addition and subtraction fact checkup, how to assess students for addition and subtraction fact fluency, how to evaluate the numerical fluency checkup, how to assign materials, and the post-assessment process. At the end of this course, there will be a quiz to determine what you have learned. The resources you will need for reference in this course and to understand the Mathnasium Numerical Fluency Program are located in the Resources tab in the upper right-hand corner. Please go to the Resources tab and download and print the following: the Numerical Fluency Program Training Manual, the 2 assessment documents, the assessor's intake form and the student page, the Levels of Proficiency Selection Guide, and the assessment record chart. The term basic number facts include all addition, subtraction, multiplication, and division problems in which students are commonly expected to recall the answers. Here is an example for each operation. 3 plus 7 equals 10, 13 minus 5 equals 8, 5 times 9 equals 45, and 120 divided by 10 equals 12. Students must know the basic facts of each operation before they can be successful with the more advanced computational algorithms such as multi-column addition and subtraction, as well as the multiplication and division algorithms. For most students, the main way they are expected to learn number facts is memorization. However, for many students who struggle with learning number facts, this is not the best way. At Mathnasium, we must teach children to create mental structures or frameworks for learning to facilitate learning material they are typically expected to memorize. Instead of attempting to memorize all the number facts, it is best for students to be taught to develop them. For many students, the beginning of the end of their mathematics education is their inability to handle single-digit addition fluently. This means to answer questions easily, accurately, and articulately. Larry says that we must ensure that students reckon or think when they are doing computation. This is done by monitoring them closely when they work and evaluating how they do their work. When monitoring students, you should look for whether their answers are found easily and accurately, or whether they are struggling to find the answers by counting on their fingers or drawing tally marks. When students can't find answers easily and accurately, it is time to intervene with various strategies to help them. These strategies are what the Mathnasium Numerical Fluency Program is all about. Before continuing with the course, let's take some time to learn the key terms you will need while learning about the Numerical Fluency Program. Select a button to see definitions and examples of the key terms. Now that you know a little bit more about number facts and numerical fluency, let's explore the different aspects of the numerical fluency program. Starting with the methodology, select a button to learn more about that aspect of the program. Once you have gone through all the different aspects, select Final Quiz to take a quiz on what you have learned. Mathnasium training materials and curriculum include techniques for helping students develop addition and subtraction fact fluency. These techniques are incredibly effective if students have the prerequisite knowledge to use them and receive proper instruction along with the appropriate curriculum. The Numerical Fluency Addition and Subtraction Fact Checkup is designed to measure addition and subtraction fact fluency and provide a clear path for how to master addition and subtraction facts for each student. Students are assessed in the skill areas needed to use the techniques. From the assessment results, a customized learning plan is created. Addition and subtraction fact fluency issues most commonly present themselves when students are solving addition facts with sums over 10, like 8 plus 5, and subtraction facts with minuends over 10, like 17 minus 9. This is where the lack of efficient techniques often leads students to rely on finger counting or other inefficient techniques. There are two primary techniques to solve addition facts with sums over 10, and one primary technique to solve subtraction facts with minuends over 10 that form the basis of this program. To attain mastery of addition facts with sums over 10, students will need to learn the two techniques which we have named up to and over 10 and doubles plus or minus 1. To attain mastery of subtraction facts with minuends over 10, students will learn the technique that we have named how far apart, up to, and over 10. In order for students to have success using the techniques, they need excellent materials, excellent instruction, and the prerequisite knowledge. The first technique we will look at is up to and over 10. To better understand the prerequisite knowledge that the student will need, let's first look at how the technique works. When asked to add 8 plus 5, a student decomposes the 5 into the part that brings 8 up to 10, which is 2, and then adds the leftover part, 3, to 10 to make 13. In order to use this technique, the student needs to be able to recall the complements of 10, 8 plus 2 equals 10, decompose single-digit numbers, 5 decomposes into 2 plus 3, and find 10 plus a single-digit number. 10 plus 3 equals 13. The next technique we will look at is doubles plus or minus 1. Let's look at how this technique works. For doubles plus 1, when asked to add 7 plus 8, a student reasons that since 7 plus 7 is 14, then 7 plus 8 is 1 more, 15. For doubles minus 1, when asked to add 7 plus 8, a student reasons that since 8 plus 8 is 16, then 7 plus 8 is 1 less, 15. In order to use this technique, students need to be able to recall doubles facts up to 12 plus 12. The last technique we will look at is how far apart, up to, and over 10. Let's see how it works. When asked 17 minus 9, the student reasons that 9 and 17 are 8 apart on a number line by taking 2 jumps. First, from 9 up to 10, which is 1, then from 10 up to 17, which is 7, and finds the sum of these jumps. 1 plus 7 equals 8. In order to use this technique, the student needs to be able to recall the complements of 10, 9 plus 1 equals 10, have mastery of 10 plus a single-digit number, 10 plus 7 equals 17, and be able to solve addition facts with sums under 10. 1 plus 7 equals 8. Now that we have seen how the three techniques work, let's look at all the skill areas that a student needs to master in order to use them and ultimately have addition and subtraction fact fluency. Starting with the prerequisite skill areas, we have addition facts, sums under 10, decomposing single-digit numbers, 10 plus a single-digit number, doubles facts, sums up to 24, and complements of 10. The assessment is structured so that a student will be assessed in each of these prerequisite skill areas, and when appropriate, they will be assigned prescriptives that address them first. Once students exhibit mastery of these 5 skill areas, they have the prerequisite knowledge to begin working through the other 5 skill areas: addition facts, sums over 10, subtraction facts, minuends up to 10, missing add-ins, facts with sums over 10, subtraction facts, minuends over 10, and missing subtrahends facts. In order for your students to find success with this program, it is absolutely essential that you assess them appropriately and ensure they have the prerequisite knowledge. The Mathnasium Assessment Numerical Fluency Addition and Subtraction Fact Checkup assesses a student's addition and subtraction fact fluency. This checkup has both written and verbal components and serves as both the pre-assessment and the post-assessment for checking addition and subtraction facts. There are 10 skill areas assessed using this checkup. Skill areas 1 through 5 are prerequisite skills that students need to master before moving on to skill areas 6 through 10. When students achieve mastery of all 10 skill areas, addition and subtraction fact fluency is attained. However, it is recommended that most students continue to receive ongoing practice with addition and subtraction facts. Select a skill area to see an example. Each of the 10 skill areas to be assessed are in numerical order as they appear on the checkup. The recommended format for each skill is outlined in the Administering the Assessment module of this course. The Numerical Fluency Addition and Subtraction Fact Checkup is designed to be administered in conjunction with checkups 1 through 4. Based on the student's computational ability, it might also be appropriate for students taking higher level checkups. Administering this assessment requires the personal attention of a trained assessor for the length of the entire checkup. It typically takes 10 to 15 minutes to complete and should be administered before the written checkup. In order to administer the checkup, you will need the following items: the Numerical Fluency Addition and Subtraction Fact Checkup, which consists of 2 components: the assessor's intake form. This is a form in which the assessor records specific information to help evaluate a student's level of proficiency in each targeted skill area. The student page, which is a page on which students write their answers under the assessor's supervision at designated times throughout the assessment process. There are 4 skill areas that require students to write their answers. The Level of Proficiency Selection Guides chart. This is a chart that contains guidelines to help assessors determine the most appropriate level of proficiency for each skill area, and a shuffled stack of Mathnasium playing cards 0 through 10, 1 card of each number. You will find the first 3 items in the Resources tab in the upper right-hand corner. On the next few slides, we will take a look at the assessment flowcharts. Let's look at the recommended way for a student to move through the numerical fluency program from pre-assessment to post-assessment. Once a student has taken the post-assessment, they will follow one of 2 paths. They will either demonstrate addition and subtraction fact mastery, or they will continue to work on numerical fluency materials until they do. We will now take a closer look at how each skill area is assessed. Addition facts sums under 10. This skill is assessed verbally, and the details of the student's responses and techniques used are recorded on the facts grid. Each fact is assessed separately. For more information on how to use the facts grid, please see the Administer the Checkup module of this course. The following are examples of the common techniques used for solving addition facts with sums under 10 that are listed in the left-hand column of the facts grid. Counting on from the larger number. When asked 3 plus 6, the student counts up by ones from 6. Counting on from 1 or the smaller number. When asked 5 plus 2, the student starts at 1 and counts up by ones, or starts at 2 and counts up by ones. Effortless recall. When asked 5 plus 2, the student answers 7 with little to no hesitation. When asked, "How do you know that?" the student answers by saying, "I know that 7 is 2 more than 5. Memorization. When asked 5 plus 2, the student answers 7 with little to no hesitation. When asked, "How do you know that?" the student answers by saying, "I memorized my facts." Doubles plus or minus 1. When asked 3 plus 4, the student reasons that since 3 plus 3 is 6, then 3 plus 4 is 7. Any other technique the student is able to articulate that is not listed. Decomposing single-digit numbers. This skill is assessed in written format with a visual aid using the first problem set on the student page. To get the student started, ask, 7 plus what number is 9? The student writes an answer in the circle on the student page, and the assessor will record the student's response into the appropriate circle on the assessor's intake form while following the procedures for using YSN rectangles. Continue in this manner for the next two decomposing diagrams. Please note the number of the problem set correlates with the number on the checkup. The first problem set on the student page is marked as number 2 because it corresponds to the second problem. This will also be the case with questions 4, 8, and 10. The next skill area is 10 plus a single-digit number. This skill is assessed verbally. Ask the student, "How much is 10 plus 3? Record the results on the assessor's intake form by following the procedures using the YSN rectangles. Continue in this manner for the next two facts. Doubles facts sums up to 24. This skill is assessed in written format using the second problem set on the student page. Instruct the students to write in the answers to all the facts that they know very well first. Then go back to the others if possible. Watch carefully and ask students to articulate their techniques if they do not immediately know a correct answer or if they immediately answer incorrectly. On the assessor's intake form, circle all the facts the student has not mastered. A doubles fact is considered mastered if a student effortlessly recalls a correct answer within approximately 3 seconds. Since there are 12 problems for the students to do on their own, it is critical to watch how students find answers to determine whether or not they are finger counting or using other inefficient techniques. Complements of 10. This skill is assessed verbally with the use of Mathnasium playing cards. Using a shuffled stack of playing cards with the numbers 0 to 10, one of each, play a game called Get to 10. To begin the game, place one card face up on the table and have the student tell you how much is needed to get to 10. Continue playing by placing cards one at a time until every card is used. It is necessary to place down every possible number once, as it cannot be assumed that if a student knows 7 plus 3 equals 10, that they will also know that 3 plus 7 equals 10. On the assessor's intake form, the bolded number in each pairing represents the card that is placed face down. Circle the pairings that are not mastered. For record-keeping purposes, it is best to make a separate pile of the cards that are not mastered and fill in the information on the assessor's intake form after the completion of the game. A complement of 10 is considered mastered if a student effortlessly recalls a correct answer within approximately 3 seconds. Now that we have covered the 5 prerequisite skill areas, we are ready to look at the other 5 skill areas. Addition facts sums over 10, subtraction facts, minuends up to 10, missing add-ins, facts with sums over 10, subtraction facts, minuends over 10, and missing subtrahends facts. Addition facts, sums over 10. This skill is assessed verbally and the details are organized on a facts grid. Follow the procedure for using facts grids. The following are examples of the common techniques used for solving addition facts with sums over 10 that are listed in the left-hand column of the facts grid. Finger counting or a similar technique. When asked 8 plus 5, the student counts up by ones from 8 using fingers, visual or tactile manipulatives. Doubles plus or minus 1. When asked 7 plus 8, the student reasons that since 7 plus 7 is 14, then 7 plus 8 is 15. Up to and over 10. When asked 8 plus 5, the student decomposes the 5 into the part that brings 8 up to 10, 2, and then adds the leftover part, 3, to 10 to make 13, adding 10 first. When asked 6 plus 9, the student reasons that since 6 plus 10 is 16, 6 plus 9 is 15. Effortless recall. When asked 4 plus 7, the student answers 11 almost immediately. When asked, "How do you know that?" the student articulates the use of the up to and over 10 technique. Memorization. When asked 4 plus 7, the student answers 11 almost immediately. When asked, "How do you know that?" the student cannot articulate an efficient technique to find the answer. Any other technique the student used that is not listed. Subtraction facts, minuends up to 10. This skill is assessed verbally and the details are organized on a facts grid. Follow the procedures for using facts grids. The following are examples of the common techniques used for solving subtraction facts with minuends up to 10 that are listed in the left-hand column of the facts grid. Finger counting or a similar technique. When asked 9 minus 7, the student counts down 7 by ones from 9 using fingers, visual or tactile manipulatives. Related facts. When asked 7 minus 4, the student knows the answer is 3 by recalling that 4 plus 3 equals 7. How far apart? When asked 9 minus 7, the student reasons that 7 and 9 are 2 apart on a number line. How much is left? When asked 8 minus 2, the student reasons that if you take 2 away from 8, there would be 6 left. Effortless recall. When asked 10 minus 3, the student answers 7 almost immediately. When asked, "How do you know that?" the student articulates the use of the how much is left technique. Memorization. When asked 10 minus 3, the student answers 7 almost immediately. When asked, "How do you know that?" the student cannot articulate an efficient technique to find the answer. Any other technique the student used that is not listed. Missing add-ins, facts with sums over 10. This skill is assessed in written format using the third problem set on the student page. To get the student started, ask 7 plus what number is 16? The student writes an answer on the line and the assessor records the student's response on the appropriate line on the assessor's intake form, while following the procedures for using the YSN rectangles. Continue this for the next 2 missing add-ins problems. Subtraction facts, minuends over 10. This skill is assessed verbally and the details are organized on the facts grid. Follow the procedure for using facts grids. The following are examples of the common techniques used for solving subtraction facts with minuends over 10 that are listed in the left-hand column of the facts grid. Finger counting or similar technique. When asked 13 minus 8, the student counts down 8 by ones from 13 using fingers, visual, or tactile manipulatives. Related facts. When asked 11 minus 5, the student knows the answer is 6 by recalling that 5 plus 6 equals 11. How far apart, up to and over 10. When asked 17 minus 9, the student reasons that 9 and 17 are 8 apart on the number line by taking 2 jumps. First from 9 up to 10, and then from 10 up to 17, and finds the sum of these jumps. Some students may start at 17, go down to 10 first, and then to 9. How much is left, splitting the subtrahend? When asked 14 minus 6, the student reasons that if you take 6 away from 14, there will be 8 left. The student does this by splitting the 6 into the part that brings 14 down to 10, and then taking away the leftover part. So 14 minus 6 becomes 14 minus 4 minus 2. Effortless recall. When asked 13 minus 8, the student answers 5 almost immediately. When asked, how do you know that? The student articulates the use of the up to and over 10 technique. Memorization. When asked 13 minus 8, the student answers 5 almost immediately. When asked, how do you do that? The student cannot articulate an efficient technique to find the answer. Any other technique the student used that is not listed. Missing subtrahend's facts. This skill is assessed in written format using the fourth problem set on the student page. To get the student started, ask, 8 minus what number is 3? The student writes an answer and the assessor records the student's response on the appropriate line of the assessor's intake form, while also following the procedures for using YSN rectangles. Continue this for the next two missing subtrahend's problems. Let's take a closer look at how to use each part of the checkup when assessing students, starting with the assessor's intake form. If you have not already done so, download and review the assessor's intake form located in the Resources tab in the upper right-hand corner. There are 4 facts grids that appear on the form. These grids are designed to help assessors obtain the necessary information to determine a student's level of proficiency in the following skill areas: addition facts sums under 10, addition facts sums over 10, subtraction facts minuends up to 10, and subtraction facts minuends over 10. There are YSN squares in the top row of each facts grid, and common techniques students use are in the left-hand column. Let's take a closer look at YSN squares. They help the assessor note whether or not a student provided timely correct responses as well as record incorrect responses. Y stands for yes, the question was answered correctly. S stands for slow, which means providing a correct answer in more than approximately 3 to 5 seconds. If there is any evidence of finger counting or counting by ones, even if it is done quickly and accurately, it should also be classified as slow. 3 to 5 seconds provides an approximate range to allow a student to slightly pause to think about the answer if it is not at the effortless recall level. The idea is not to actually count the seconds, but to get a feel for whether or not the student is providing correct answers through efficient techniques within a reasonable time frame. N stands for no. The question has not been answered correctly. Incorrect answer box, a designated space to record an incorrect answer. It is important to gain a clear picture of a student's thought process to properly evaluate their level of proficiency in each skill area. Start by asking the student about each fact with the following question form: how much is this plus that? Or how much is this minus that? If a timely correct response is provided, circle Y. If the technique to answer the question is not obvious, ask the student, how did you get that? After receiving the student's response, check the appropriate technique box and record any helpful notes within the box. If an incorrect response or no response is provided, circle the N and write the student's response, if applicable, in the incorrect answer box. When asking a student a number fact and an immediate correct response is provided, circle Y and write a check in the effortless recall or memorization box. In this circumstance, it is often necessary to investigate whether the student has effortless recall of the fact or if the student acquired the knowledge through memorization. This distinction can be very important. Of course, we want the facts to ultimately become second nature to students, but we much prefer that they acquire this knowledge through efficient techniques. When students have efficient techniques for figuring out the facts, they don't ever have to worry about forgetting them. Also, students will be able to use their knowledge of efficient techniques for solving basic number facts in other contexts, such as applying the up to and over 10 technique to add over multiples of 10, like 18 plus 6. When investigating further, it is important to ask a student, "How do you know that?" instead of "How did you get that?" The difference in these two questions lies in the idea that asking, "How did you get that?" implies that a process occurred to figure out the answer. When an immediate correct response is provided, the student most likely just knows the answer. If students have difficulty answering this question, encourage them to prove their answer. Look to see if students have efficient techniques to figure out the answer. This information will help when evaluating levels of proficiency and assigning materials. If a student has an efficient technique to answer a fact, draw a check mark in the appropriate technique box in addition to the effortless recall or memorization box. If students do not have an efficient technique to solve a fact, write an M alongside the check in the effortless recall or memorization box. Note that it may not be necessary to ask students to prove their correct answers for all questions that they have immediately answered. In the next slide, we will look at an example of a completed facts grid of question number 6, addition facts with sums over 10, where we know effortless recall was the technique. Let's listen to a sample conversation while seeing how the facts grid should be filled in when noting effortless recall. How much is 7 plus 8?
15.
Good job! How do you know that?
Well, I know that 7 plus 7 is 14. 7 plus 8 is just one more.
That's a great way to think about it. How much is 6 plus 9?
15.
How do you know that one?
I know that 6 plus 10 is 16, so 6 plus 9 is just one less.
Nice work. How about 8 plus 5?
13.
And how do you know that?
I just know it.
Well, see if you can think of a way to prove it.
Okay. If I take the 2 away from the 5 and add it to the 8, that makes 10. And I can add the leftover 3 onto the 10 to make 13 altogether.
Well done. Okay, last one. How much is 4 plus 7?
11. And I can figure that out the same way as I did the last one.
Let's listen to a sample conversation while seeing how the facts grid should be filled in when noting memorization. How much is 7 plus 8?
15.
Great! How do you know that?
I don't know. I just know it.
Can you think of a way to prove it?
I can count up by ones on my fingers.
Okay, we'll talk more about that later. How much is 6 plus 9?
15.
And how do you know that one?
Well, I just memorized all my facts.
Oh, I see. How much is 8 plus 5?
13.
And how much is 4 plus 7?
11.
Good work. Slightly different from the YSN squares, there are 4 skill areas that contain YSN rectangles. Appropriate use of YSN rectangles helps determine a student's level of proficiency in each of these 4 skill areas. These rectangles are designed to keep track of the number of correct and incorrect responses, as well as slow correct responses. There is also a finger counting checkbox to use when a student uses finger counting or a similar technique to find the answer. See the example of the assessed missing subtrahend facts. The procedures for using YSN rectangles are generally the same as using YSN squares, except that there is no incorrect answer box and only one technique box, the finger counting checkbox. Let's look at an example of appropriately filling in the YSN rectangle when a student answers correctly by finger counting. The assessor did the following steps: circled Y because a correct answer was provided, circled S because the student's response was slow according to the definition, wrote a check inside the finger counting checkbox because the student finger counted. Now let's look at another example where the student provides the incorrect answer by finger counting. The assessor did the following steps: circled N because an incorrect answer was provided, and wrote a check inside the finger counting checkbox because the student finger counted. The following are the definitions for each level of proficiency. No knowledge, exhibits no understanding of how to get started on the task at hand. Awareness, understands the task at hand, but does not have efficient techniques for finding the answers. Competency, has efficient techniques for finding the answers, but is not totally consistent in getting right answers in a timely fashion. And mastery, is totally consistent in getting right answers in a timely fashion using efficient techniques, and can generally explain the thought process employed to get the answers. The general guidelines to help assessors determine the appropriate level of proficiency for each skill area are by using indicators of lack of mastery. This graphic appears in each skill area. The letters in this graphic stand for the 4 levels of proficiency, which are no knowledge, awareness, competency, and mastery. Once the checkup has been administered, the assessor will determine the appropriate level of proficiency for each skill area and circle the corresponding letter on the checkup. We will now look at definitions for these levels and explain how to determine where a student falls within these levels of proficiency. The levels of proficiency chart shown here is located in the Resources tab in the upper right-hand corner. Have this chart handy when evaluating student responses. Student indicators help the assessor determine a student's level of proficiency. An indicator is an incorrect response or a slow correct response. Remember that a slow response is defined as providing a correct answer in more than approximately 3 to 5 seconds. If there is any evidence of finger counting or counting by ones, even if it is done quickly and accurately, it should be classified as slow. Facts are considered mastered if a student can effortlessly recall a correct answer within approximately 3 to 5 seconds. As you evaluate the assessment results, use the assessment record chart to record the level of proficiency for the student for easy entry into M2. Please see the sample chart completed here. When entering assessment results in M2, use the following guidelines. Using the partial credit feature, enter no knowledge as incorrect, awareness as 25%, competency as 75%, and mastery as correct. Learning plans are generated as usual with a unique prescriptive for each skill area. Once students complete the prescriptives and focus-ons in their learning plans, the numerical fluency checkup should be re-administered as the post-assessment. Once the post-assessment is completed and levels of proficiency selected, enter the results in M2 and use the comparison chart to report progress. If all assessed skill areas are mastered, then students have attained addition and subtraction fact fluency. At this point, it is appropriate for students to begin or continue working within their learning plans constructed from the written checkups. If it is determined that students have not yet mastered all the skills, reassign any necessary prescriptives or related focus-ons and administer another post-assessment after students have completed the reassigned materials.